Today I want to talk about arrays. So we say array is a variable that can store multiple values of the same type. The values are stored in consecutive memory locations. When you want to store values of the same type, we have a data structure named arrays. We declare an array using open and close brackets. For example, we can say const int I size equals to 5. Int test I size. In this example, I'm defining an array of size 5. This I size is the size of the array. This open and close brackets, you can include the size of array there. When you say int test I size is 5, you're defining an array of size 5. Computer will allocate the following memory: element 0, 1, 2, 3, 4. Each box is a memory location for one element in the array. The indexes in array, they start from 0, they go to n minus 1. So in the definition of array, we say int tests I size. This I size is the size of the array. Int is the data type of the array elements. Tests is the name of the array. So we say the size of an array is the number of bytes allocated for it, which is number of elements times bytes needed for each element. In this example, assume integer uses 4 bytes and double uses 8 bytes. When you say const int I size equal to 5, d size equal to 10, int test I size, I'm declaring an array of size I size, which is 5. It can hold 5 integers. Array occupies 20 bytes. In this example, this array will occupy 20 bytes. When you say double volumes d size, we have an array of 10 doubles. Since each double takes 8 bytes, this array will take 8 times 10, which is 80 bytes. If you want to access elements in array, each array element has a subscript used to access. The subscripts, they start at 0. The first element, the subscript is 0, then it's 1, then 2, 3, 4. In this example, I have an array of size 5. The indexes are 0, 1, 2, 3, and 4. If I want to put something in the first one, I can say test 0 equal to 79. 79 goes in the first box. If I say cout test 0, the first one will get displayed. If I say cn double right arrow test 1, I can put something in element index 1, which index 1 is the second one. I can say test 4 equal to test 0 plus test 1 to add the first one and second one and put it in index 4. If I say cout test, that's illegal. You couldn't use the name of array to display the content of it, because the name of the array is a pointer to the first element in the array. So when you declare an array, this is how you declare it. You put the data type, you put the name of the array, you put the size and brackets. If you want to put something inside your array, you can use the index. If you want to display something from your array, you can use the index. Array subscript can be an integer constant, integer variable, or integer expression. For example, I can say C and double right arrow tests 3. In this example, I am using the cn statement to put something inside index 3 of my array, int constant. I can say cout double left arrow test I, which I is an integer variable. I can say cout double left arrow test I plus j, which I plus j is an expression that will get evaluated to an integer. So when you want to declare an array, you can declare it using the data type. You give it a name and then you declare it. If you want to access something from the array, inside the array, you can use the indexes. You can access all array elements. To access each element of an array, we use a loop. We let the loop control variable be the array subscript. For example, we can say for I equal to 0, I less than 5, I plus plus, CL test I. In this example, I'm accessing all the elements in the array and I'm displaying them. This is another example that shows how you can work with arrays. We have a const int I size, which is 5. We say int sales I size. So I have this array of integer, which the size is 5. ifstream data file is used to work with false. When you say ifstream, you're using a class named ifstream, which is defined in ifstream. With data file.open sales.dat, I can open this file. I say if not data file, see out error opening data file. If I couldn't open the data file, I display an error. If I could, I go from 0 to size, I get the data and I put it in sales day. Then I close it. So you can see how we can get array data from a file and then store it inside it. Like in this example, I will talk more about files, but this ifstream is defined in a library named ifstream, and then you can use it. If you want to send array data to a file, you can open file using ifstream object. You use a loop to write each array element to the file, then you close it. There is no bound checking in C++ when you work on arrays. An invalid array subscript can cause program to override other memory. For example, when you say const int I size equal to 3, int I equal to 4, int num I size, you're declaring an array of size 3. When you have an array of size 3, the indexes can be 0, 1, or 2. If I say num I equal to 25, I'm putting 25 in index 4. There is no bound checking. It will go out of range and it may go someplace in the memory and overwrite something. When you work with arrays, be careful. There is no bound checking. It's very common that sometimes the programmer, they go off by 1. So when you're working with an array, when you want to define an array, use an array, be careful because it's possible that you may go out of the range. So these most happen when a program accesses data one position beyond the end of array or misses the first or last element of an array. If an array has size n, the subscript range from 0 to n minus 1. You could initialize an array. An array can be initialized during program execution with assignment statements. For example, you can say test 0 equal to 79 or test 1 equal to 82. It can be initialized at array definition with initialization list. You can say const int I size equal to 5 or int test I size equal to 79, 82, 91, 77, and 84. When you define an array, you could initialize it. How you can initialize it with equal, and then you can put a list of numbers inside the array. You may choose to declare array to be 1 larger than needed. This allows you to use the element with subscript 1 as the first element and may minimize off by 1 errors. When you declare an array, sometimes you can add 1 to the size of the array. And when you want to put something in the array, you can start from index 1 rather than starting from index 0. We say the element with subscript 0 is not used. This is most often done when working with order data, like months of the year, days of the week. You could partially initialize an array. If array is initialized at definition with fewer values than size declarator, then the remaining elements will be set to 0. If you have an array, which the size in this example is 5, and then you put 2 numbers inside it, everything else becomes 0. We call this partial initialization. Initial values are used in order. You cannot skip over elements to initialize or non-contiguous range. You couldn't skip them. You cannot have more values in initialization list than the declared size of the array. So when you define an array, you can partially initialize. Like in this example, I'm just putting 2 numbers. Everything else becomes 0. C++ can determine the array size by size of the initialization list. In this example, I say short quizzes equal to 12, 17, 15, and 11. Since I'm putting 4 numbers inside my array, the size of the array becomes 4. You must use either array size declarator or initialization list when the array is defined. So there are two different ways of, when you have an array, the size of the array has to be known. So in this example here, the size of the array is 5. It means I can put 5 numbers there. The other way to define an array is by initializing the array to some numbers. So when you do that, the array size will be set as how many numbers you put inside it. So you must use either array size declarator or initialization list when an array is defined. There are some other ways to initialize variables. For example, you can say int length 12. This is the same as int length equal to 12. In C++ 11 and higher, you can say int length and 12 inside open close braces. So there is another for loop that we call it range-based for loop. This is the general syntax for range-based for loop. We say for data type var colon array state. This is an example of a range-based for loop. You can see we say for and score calling grade sum plus equals score. In this example, we want to find the sum of the elements of the array. We say sum equal to 0. This for loop will add the scores to sum for each score inside this array. We call this range-based for. So range-based for loop is kind of different than regular for loop. The data type must be the type of the array. A var will hold the value of successive array element. A statement can be a single statement or a block of statements. This is another example of a range-based for loop. We say const int I size equal to 3. Int I size grades. I have an array of size 3. I say for int ampersand score calling grades, cout enter score cn score. This means for each score inside the grades, I want to get this score. If you pay attention here, there's an ampersand here, which I'll talk more about it later. But that's a reference variable. So you could process array contents. Array element can be treated as ordinary variable of the same type as array. It can be used in arithmetic operations and relational expression and etc. For example, you can say if a principal amount 3 is greater or equal to 10,000, interest becomes principal amount 3 times interest rate 1. Else interest is equal to principal amount 3 times interest rate 2. In this example, you see we can use the if statements and then arrays and access different elements inside array. So if this condition is true, the interest will be interest rate 1 times principal amount 3, which this is an element inside your array. If this condition is false, then interest will be different, which is the rate 2 times principal amount 3. You could increment and decrement array elements. You could use plus, plus, and minus, minus. For example, when you say test I, when you say test I plus plus, this will add 1 to the element to the element at index test I. When you say test I plus plus, this will increment I, but doesn't have any effect on the test. So when you use the plus plus, if you put it after the array element, it will add 1 to that element inside the array. If you put it after the I, it will add 1 to the index. It will go to the next index. You could copy one array to another one. You cannot copy with assignment statement. You couldn't say tests to equal to tests. This will not work. You must instead use a loop to copy element by element. For example, you can say for int index equal to 0. index less than I size, index plus plus, test to index equal to test index. You can go one by one, access each element inside one array, and then you can put it inside another array. In this example, the indexes will change from 0 to I size minus 1. You copy one array inside another array. You could check to see if two arrays are equal. You cannot compare two arrays using a single expression. You couldn't say if test 2 equal to tests. You can use a while loop with a bool variable. You can say bool r equal to true, index equal to 1, while r equal and index less than I size. In this example, this r equal is true. If index is less than I size, it's true, and anything that is true is true. If this condition matches, it means if the test index is not equal to test to index, this r equal becomes false. It means you have two different arrays. You will check the elements inside the arrays one by one. If you find two elements that they don't match, then you will make the r equal false. You add to the indexes and you keep going until you check all the elements inside the array. With this code, with this while loop, you can check to see if two arrays are equal or not. You can find sum and average of array elements. In this example, I say float average and sum equal to 0. I have a for loop that I go from 0 to size. I add tests t-num to the sum. This for loop will find the sum. Or you can use C++11 range-based for loop. In this example, I'm using the range-based for loop to find the sum, which if I divide the sum by I size, then I can find the average. So you can find the largest array element. You say largest equal to test 0. You can assume that the first element in the array is the largest one. You go from index 1 to the last one. You check them one by one. If any element is greater than the largest one, you put that element inside the largest, and then you display the largest. You could use a similar logic to find the smallest element inside an array. So I want you guys to study this chapter and get familiar with arrays. There is a difference between using arrays and using simple variables. An array is probably not needed if input data is only processed once. If the input data must be processed more than once, an array is probably a good idea. For example, if you want to calculate the average, determine and display which values are above the average. At the average and below the average, array can be a good choice. If you want to find the sum or average of some numbers, if you want to find the largest or smallest of a set of values, then you will not need an array. You could use partially filled arrays. The exact amount of data may not be known when program is written. The programmer makes the best estimate for the maximum amount of data and sizes the arrays accordingly. Sometimes you have an array that you don't know what's the size. You can make a guess or an estimate, and then you could create your array based on that guess. The programmer must also keep track of how many array elements are actually used. So we have something we call it C-string, which I did talk about it. In this example, when I say string city, I'm defining a string. I say cout enter city name C and city. I'm getting a string and I'm putting inside this city. If the user puts SALEM, I have city 0, city 1, city 2, city 3, and city 4. So you could get the entire string at once, or you can do it one element at a time by using the subscript. So strings are actually an array of characters. When you get a string and you store it in city, you have stored an array of characters. You could use parallel arrays. We say two or more arrays that contain related data are parallel arrays. The subscript is used to relate arrays. Elements at the same subscript are related. The array do not have to hold data of the same type. In this example, we have three different arrays: name, average, and grade. We have this I size, which is a constant integer. So we call these parallel arrays, means because there's a relationship between these arrays. These arrays, they have the same size. They have different types. It means they can store different type of data. If you want to process parallel arrays, you can use a for loop. You say for if I equal to 0, I less than I size I plus plus, see out name I, average I, and grade I. It means I'm accessing each element inside my arrays and I'm displaying. This I size is 5. So the I will become 0, 1, 2, 3, and 4. This is how you can process parallel arrays. You can also define two-dimensional arrays. For example, I can say int exams 43. It is like a table in a spreadsheet. We use two size declarations and definitions. We have number of rows and number of columns, which number of rows is 4. And number of columns is 3. In this example, we have an array of size of 4 by 3. It means we have 4 rows and we have 3 columns. The first element in the array is exams 0, 0. Then we have 0, 1, 0, 2. This is the first row. Second row, we have 1, 0, 1, 1, 1, 2. We have 2, 0, 2, 1, 2, 2, 3, 0, 3, 1, 3, 2. We use two subscripts to access elements. For example, I can say exams 2, 1 equal to 86. I can put 86 and exams 2, 1. We use both indexes to access elements in the array. When you use access an element of a two-dimensional array, we use both indexes. The first subscript 2 indicates the row in the array. The second subscript 1 indicates the column in the array. Two-dimensional arrays are initialized row by row. For example, I can say int exams 2, 2. I can initialize it with 84, 78, 92, and 97. We can omit the inner open and close braces. In this example, I'm defining a two-dimensional array. I'm putting 4 numbers inside it. We can take out these inner braces. We can pass a two-dimensional array to a function. For example, I can call a function and pass exams there. We use the array name and the number of columns as arguments in the function call. We use empty open and close brackets for row and size declarator for the number of columns and prototype and header. In this example, I have a function, get exams. I'm passing a two-dimensional array to it, which is type of integer. The number of rows is here and number of columns is here. But if you see when you're passing it, we leave the number of rows empty. We define the number of columns. This is the prototype. In the header, we put the name of the array data type. We leave the number of rows empty, number of columns is specified, and we have integer rows. It means the number of rows are the second argument of the function. I'll talk more about functions. You could traverse a two-dimensional array using two different for loops inside each other. We use nested loops, one for the row and one for the column, to visit each array element. Accumulators can be used to calculate the sum of the elements row by row, column by column, over the entire array. We could have arrays with 3 or more dimensions. You can define arrays that have many number or dimensions, like short, rect, solid, 2, 3, 5. Double, time gridded, 3, 4, 3, 4. We could define arrays more than size of more than 2 dimensions, like 3 dimensions or 4 dimensions. So I want you guys to study this chapter. With typedef, we can define a new type. For example, when you say typedef unsigned int UINT, I'm defining a new data type, which is unsigned integer, and I'm naming it UINT. We have some specific types in C++, which I talked about. If you want to define your own type, you can use the type. When I say typedef int year array months, I'm defining an array of integers. So if I say year array high temps and low temps, I'm creating two different arrays, which are based on this type. So with the typedef, you can create a new data type. This is how we use the typedef, which helps you create a new data type and then use it. I want you guys to study this chapter. I have assigned arrays in the Zybook. I want you guys to work on that. If you have any questions, let me know.